a factor form. Critique and explain. Corey wrote an equation in a factor form, y is equal to x plus a times x minus 2, to represent a quadratic function. Kimberly wrote the equation y is equal to x squared plus 6x minus 16, and Joshua wrote the equation y is equal to x plus 3 squared minus 25. A. Do all the functions represent the same function? If not, whose is different? Explain algebraically. So here I'm just going to explain verbally all of these questions. First of all, the equation of the Corey is in a factor form, and the equation of the Kimberly is in the standard form, and Joshua's equation is in the vertex form. But now, for example, if we want to prove algebraically all these three equations are the same, then we have to expand the Corey's equation into the standard form, which we multiply the first binomial with the second binomial, and not probably, but for sure we are going to come in this equation. And then the Joshua's equation, again, we expand this form, what is the x plus 3 squared, times x plus 3 times x plus 3 minus 25, and we're going to come then we can convert into the standard form. When we convert into the standard form, we can then compare all the three equations. But in this case, all three equations are the same, but you can prove it at home. So that is algebraically. But if we want, for example, have to find out graphically all of three are the same, we can plug in all three equations in a graphical utilities or in a Desmos, and we can find out all these three equations produce the same parabola. Now, in a B, how else could you determine if all three equations represent the same function? How could you all of three? So as I mentioned already, I answered in the A. We can determine in algebraically, and by expanding all of them to convert in one equation. But again, I just mentioned one scenario when, for example, we can the Corey's equation and Joshua's equation convert into the standard form. But we can do the opposite. We can, for example, all these two equations, for Kimberly equation and Joshua equation, we can convert into the vector form. But also, we can Corey's equation and Kimberly's equation to convert in the vertex form. So all of them, they can go in, we can convert in each other's form, in all three forms. And as I mentioned, and graphically, we can find the graphically, do they have, all of them have the same graph. If all these equations have the same graph, it means all of them are the same. And here is missing a little bit and down, but I will try to give you full information. What information can Corey's form help you find that is more difficult to find using Kimberly's and Joshua's form? The Corey's form here is much easier because we can find the x-intercept when we have a factorized in this form. So these factors, for example, we equate with a 0, x plus 8 equals with 0 and x minus 2 equals with 0, and in that way we can find the x-intercepts. So, or zeros of the function, and when we find, it's much easier to find zeros of the function in the factored form than it is in the Kimberly's form or in the Joshua's form. This is the advantage of the factored form of quadratic equations.